Okay, welcome to another Tactical Technician video from Diagnation. Today's video we're going to call no crank. Called the no crank scope drill. Basically, when we have an intermittent no crank and where we want to kind of set our equipment up to see what could be the possibility. Take a screenshot or a snapshot of your schematic here, and you want to use it during this demonstration. We're going to look at a bunch of different scenarios, and we're going to do it in a different kind of style. We're gonna first of all, I'm going to show you a normal cranking vehicle where all the signals are good. We are on 8 channels, and channel A is, as you can see, is the output of our ignition switch, the start pole on our ignition switch. Channel B red is the input on the power side of our starter relay. Channel C green is a connector on the outside of our starter, the latching output of our starter relay between the starter relay and the starting motor. Channel D yellow is right at back probed into the connector at the starter solenoid right there. Channel E purple is at the input side of the park neutral switch, which should be closed obviously in park or neutral to complete the circuit through the starter relay. Channel F gray is at the ground connector where the starter relay grounds. Channel G is an amp clamp. That is the current flowing from the starter relay to the starter solenoid to create the magnetic field to latch the starter. There you can see the starter solenoid. That's the black coily looking thing there, and the starting motor, which is there, the red, as you can see. Channel H burgundy is a amp clamp around our control circuit, which basically validates that our circuit is complete through the control side of the relay. Now, I realize that in diagnosing this, you don't have to use 8 channels. I always said a good combination is an amp clamp and a voltage probe with a 2-channel scope, and you can learn a lot of information between the relationship of voltage and current. Another thing I want to point out is that always be mindful that the hot lead can carry current, because that in itself can cause a no crank, as also in addition to we have to have good solid ground mounting for the starter, because without that, current just does not flow and the system doesn't work right. We're going to look at 6 different situations, as you can see in green. Those are 6 scenarios numbered 1 through 6 with green circles around them. Green implying the green crusties, or something that would cause a lot of resistance in a circuit and make the circuit not work properly. We will go through one at a time. I won't tell you what number is causing the no crank. I want you to try to learn just by looking at the scope patterns and looking at the difference of each of the scope patterns to determine where the what number is causing the no crank. And then right before you do that, you want to freeze the video so you have the scope capture in front of you and you have your schematic, and just analyze everything and take a look, and then write down what number you think is causing the no crank. Be 1, 2, 3, 4, 5, or 6. It's only one at a time. And as I said, individually, these problems every one of them can cause a no crank condition, as you could look at the schematic. So basically, I will go to the scope, and then we will start going through the scenario. First, we're going to look at a normal cranking vehicle, and we'll look at the signals, what they look like. Okay. Let me get that. All right. Okay. So this is going to be normal cranking, and we'll look at okay. So let's make sure we got a good okay, here we are, and let's make sure you guys and gals got a good view here to watch this thing. Okay, you can see it on the scope. That is a normal cranking vehicle, and everything is where there are no glitches. And look at your schematic, and we'll take one channel at a time. We'll go down the line just till we get familiar with this multi-channel diagnostic procedure. Blue is the outlet from the ignition switch, and we're strong. We're at probably cranking voltage. We're about 9.8 which is expected in a good cranking circuit. Red is our feed to our relay, which is good. Also, that's about the same as blue. You can see it there. See, green is our output, where our relay is latched and closed, and there's voltage on the output side of the relay. D is yellow. That is power right at our starter, which is good. We can see there where we're strong there, maybe a little voltage drop, but nonetheless we're a high voltage at the starter, ready to crank it. Channel E is that is the ground side of our starter relay, which is going to be a low voltage. That is the ground side of the starter relay control coil. So that's going to be low. We'll look at the millivolts there. We're looking about 226 millivolts. So that's low, which we'd expect. Channel F gray is also on the ground side of the control of the relay. That's right here. That is going to be low also. We have current flowing and a low voltage. That tells us that circuit's good. As far as our current flowing, we'll look at our burgundy channel. Okay, that is the current flowing through the relay coil. That's the control coil. You can see the little pin will help out blow that thing up, and you can see right here, we got a little, the coil current starts to flow. It's not a lot of amperage. I'm going to say about, what do we got as far as amperage? Maybe about 80 milliamps thrown through that coil. But then unless that latches the relay, creates this magnetic field, and the relay closes, and the circuit is good. So this is kind of a known good cranking situation. As I said, voltage strong on the blue, red, the green, and the yellow. Our current is flowing properly. Okay, I'm sorry. This is our current flowing to our starter solenoid. This is going to be about, I'm going to say 10 to 11 amps. Okay, well, we got about 14 amps. That's a pretty good pull. And also we got validation because we can see some relative compression in the cranking circuit on orange. So I'll stretch that a little, and plus you can see that. Okay, I just wanted, for grins, we'll just take a look at that. That's pretty much relative compression, and that's because the starter is cranking and the cylinders are going through their compression strokes. So this is kind of a good baseline for a good cranking car. Now I'm going to pick 1 through 6, and then you stop the video and you tell me, or you write it down, and then I'll tell you the answer once the video resumes of what's causing the no crank. So here we go. So I'm going to go to the file, and then we're going to go to and see what we got. And okay, let me see. Okay, take a look at our pattern. Take a look at your schematic and take a look at what we have and what we don't have. This is the vehicle cranking, okay? And where are we strong, where are we not strong? Take a look at our blue, and we've got full voltage here on blue, okay? This is pretty much where the key is on the start position. So we're high on blue, we're high on red, so we know we got power to the starter relay. We don't have any action on green, so we have not latched. Okay, we're unlatched. How does yellow? We have nothing on yellow because obviously we're unlatched. Let's look at our current flow. Okay, we have current flow on. Let's look at that. Okay, all right. Okay, no, current flow is burgundy. I'll get this color clash. We don't have current flow on our channel H. Now look at that schematic, and that would be that's kind of a telltale sign something's up there. No current flow on H. We have we're high on purple. Take a look at that. If you look at that schematic, and right there, the voltage on purple is the same as the blue and the red. That tells us something. So with all that information, take a snapshot of this and just analyze that circuit, and then I'll come back and I'll, take your time, freeze this video, and then I'll come back and then I'll explain what part of the circuit was causing the no crank. Okay, I'm back. All right. The part of the circuit that was causing the no crank is number 5. Right at the park neutral switch were open. That thing did not close. When that thing did not close, we don't flow current through the control part of the relay, which tells us that the burgundy has no current flowing through it. You can see right there. We have full voltage on purple. So right before the park neutral switch, the voltage sort of deadheads there. It stops there because it has no place to go. That's why it's going to be high there, as it doesn't drop low like it should if it were the voltage drop of a good circuit. So nonetheless, that's our voltage going high at our purple test point because our park neutral switch never closed. And obviously it never closed. We never latched the relay. So green will not be high because the relay didn't latch properly. So green is low and yellow is low because obviously the starter didn't get fed. So anyway, that is position that is problem number 5. Okay, I'll go to the next problem and see what we can do, how we'll deal with this. Okay. Okay. All right, here it comes. It's loading on the screen. Make sure our camera's still going. Okay. Okay. This is our second problem. Take a look at it. Now this is we're going to have to do some deduction here. This is a no crank. All right. Take a good look at everything on your schematic and our underlying symptom, which is a no crank. Nothing is moving up. Okay. You can see the action of me trying to start the car here. Blue is low, red is low, no current flow. So take a look at that schematic, and this one should be pretty easy. And I'll freeze the video and take a look at everything, and I'll be back and I'll give the answer. Okay, the answer is problem 1. It was the ignition switch didn't latch properly. When that switch does not latch, we obviously are not going to have anything on blue or red. So if we were in a diagnostic situation like this, we'd go upstream. We want to make sure the ignition switch is getting fed and things like that. Or in essence, we could hot feed this terminal with like a power probe or something to see if the thing started to crank. But nonetheless, this would be an indicator of problem number 1. So let me go to the next one and we'll do the next problem. Okay. Okay, coming up on the screen. Okay, take a look at this screen. Let's talk about it and analyze it. See what we have and what we don't have. Okay, we're strong on blue. Okay, our ignition switch closed. We're strong on red. Our power got to our starter relay. Okay, we did not latch because I'm sorry, we did latch. My bad. Okay, we're strong on green. Take a look at that as you look at your schematic, but look at our yellow. We're actually strong on yellow. Okay, that's got to tell us something, that our starting circuit is good, and we don't have current flow on the starting solenoid. You see how orange is flat? It's not getting into the solenoid, and our control solenoid is flowing current. So everything is good in this situation, and our problem is problem number 4. So just bear that in mind, that the current is not able to flow into the starter solenoid because of that connection at 4. So when you look at all these scope patterns, you sort of deduce that the telltale sign is we have power right up to the starter, but no current flow on orange right here. So let's go to the next one, and here we go. Okay. All right. Let's look at this one. This is the same symptom. It's a crank no start. On this guy, we're high on blue, we're high on red, we're on green, we're low. Okay, so our relay is not latching. as far as gray, look at gray. Gray is our ground side of the starter relay coil, and that's high, that's elevated. That's got to tell us something right here. We're almost battery voltage there on our gray test leads. Look at your schematic, and it's got to tell you something. We have no current flowing through our coil, through our control coil, our starter relay, and obviously no current flowing through to our starter solenoid. So with all this information, just freeze the screen and come back, and I'll give you the answers to what part of the circuit is the problem. Okay, I'm back. It is problem number 6. The ground at the starter relay ground is compromised, and it's not letting current flow all the way to ground. So that would give us high voltage on our test point in gray and purple, but not going through that, and it would inhibit current from flowing through the coil to latch the relay. So, okay, our next scenario, here we go. Let's take a look at this. Okay. Okay, take a look at this one. This is another no crank. Let's take a look where we are. Okay, here we are. We got our situation. We're high on blue, so our ignition switch is good. We got power to our relay as indicated on the red going high. Our relay closed as indicated on green. Okay, we have current flowing through our control coil. You can see right there, and let me see if I can show you that pintle hump. You can see that. I just want you to notice that. It looks like a pintle hump right there. That's something to bear notice, but that's our coil in our starter relay. So our starter relay control circuit's good. So where why don't we have current flowing to the starter solenoid? So let's look at our yellow. Okay, our yellow is low. If you look at your schematic, we just don't have the full voltage at yellow, and we do have it at green. So look at your schematic and tell me which particular spot in the circuit is causing the no crank. You know, freeze the video, take a look at the scope captures, and I'll be right back. Okay, the problem is problem number 3. You can see that connector there, where that should become open. It prevents current from flowing through to the starter solenoid, though it would show high on the green channel, but low on the yellow channel, because that's where our spot where our circuit's compromised. So now we'll go to the final one, and here, and let's take a look. At this situation. This is another crank but no start. I'm sorry, a no crank. Okay, and here we are. We've got a couple of them. Okay, here's our situation. Our no crank. Our blue is strong. Right here you can see blue at full voltage. We're low on red. That pretty much seals the deal. We have no current. None of our amp lamps are flowing current, and there's obviously a reason for that. If you can look at the schematic, this one is pretty fairly obvious to figure out. So freeze the video, and then I'll come back and tell you what the answer is. What of the green spots of the 6 is causing this no crank? Okay, I'm back. It is spot number 2, which is obvious. You can see that connector between the ignition switch and the starter relay. If that should open, it's nothing really much going to happen. We're not going to get any current flow through the control side of the relay, and obviously nothing through the latching start of the relay to the starter solenoid. Anyway, I hope you've enjoyed this video, and this is this is Mark from Diagnation signing off, technical technician, and all the best.